Hello. Today I wanted to talk about XDP SYNPROXY again. And so I ported the XDP SYNPROXY from the kernel self-test under kernel bpf programs XDP XDP SYNPROXY. So I ported this code to the bpf examples repository from the GitHub. So under this bpf examples, by the way, this bpf examples is under XDP project repo. Okay, so under XDP project bpf examples, it shows real practical examples for bpf. So I forked this repo and then ported XDP SYNPROXY to this repo. And here is a README to how to run this XDP SYNPROXY sample application. And so I tested under Ubuntu 22.04 with a 6.2 kernel. And so here is the IP table rules that is required for the XDP SYNPROXY. And here is how you can run this XDP SYNPROXY. Yeah. So, but today I actually want to talk more about how to deploy XDP SYNPROXY in Kubernetes cluster as a DaemonSet, which means you can run a XDP SYNPROXY program in each Kubernetes node and to protect the node from SYN flooding attack. And here I shows a command to deploy the XDP SYNPROXY DaemonSet. And I have two Kubernetes node. So here is the two XDP SYNPROXY running. Okay, so yeah. By the way, I run this Kubernetes cluster with Fnino CNI. So the Fnino still use the netfilter IP tables for the traffic direction. So if you run Kubernetes with a Selenium CNI, which bypass the netfilter path, so this XDP SYNPROXY would not work with a Selenium CNI because XDP SYNPROXY still use netfilter SYNPROXY, still use netfilter collection tracking and netfilter SYNPROXY modules. But the Selenium CNI bypass netfilter, so that does not work together. But this XDP SYNPROXY work with any CNI, any netfilter or IP table based CNI like Fnino. Okay, so yeah, I'm going to show you a demo here, and so I have so this is my K3s Kubernetes cluster, and so right now I have Nginx pod running. And now I'm going to deploy the XDP SYNPROXY DaemonSet let me show you the XDP SYNPROXY DaemonSet. So I put the XDP SYNPROXY as the name, and so here is the spec host network true, because we want to attach the XDP program to the host, to the node network interface. So this pod needed to have a host network access. And then here is the XDP program with arguments, and those are the arguments, and this is the interface, the Kubernetes node interface we want to attach the XDP program to, and these are the this is the XDP kernel program we want to attach, and here is the port that we want a SYNPROXY for. We wanna attach the SYNPROXY and run DDoS protection for SYN flooding on the port. And this is the image I built from the bpf-examples repo. Okay, so actually in the README here, I think I have the instruction to build the XDP SYNPROXY container, and you can also run it as from Docker, but I put in the DaemonSet. So yeah, so I push the container image to the Docker hub, and then so I can pull the image from the DaemonSet. So these are the after the XDP SYN program is attached to the load interface, we needed to set up the IP table rules for the node interface, and for which port we want to do the DDoS SYN flood DDoS protection. And so, for example, this is a port listening on the load so I have load port services. So I have a load port services, and it has a port 32506, and so I want to do the SYN flood protection on this port. So that's why I put the in the DaemonSet I put the ports here because we needed to set up IP table rules for this port specifically. And here is a pre-stop command shell we want to run. Like if we want to stop the XDP SYNPROXY, we needed to remove this IP table rules on this interface to these ports. So you can customize your load, customize to your node interface and to your ports you want a protection. And yeah, so for the capabilities, we need a let admin capabilities and a privilege true. Okay, so for the volume mount, we also want to have this FSBPF file system mounted, so we can run the XDP program properly. We can attach the XDP program to the node properly with this BPF FS file system mount. Okay, so I have two nodes here. I have two K3S node here. So to load ready state, this is the load IP. Okay. So we can check right now on the node interface, since we're going to attach the XDP program to this load interface ENS9. Okay, so right now there you can see here there is no XDP program attached. So because usually when you have XDP program attached to the interface, you would see a XDP in line here, or XDP generic if it's a SKP mode. So, but right now we don't have XDP program attached. But after I deploy the XDP SYNPROXY DaemonSet, we should see XDP program attached to the node network interface. So let's get a pod, and you can see here there's a 2 XDP SYNPROXY DaemonSet. We can, so each node has a XDP SYNPROXY daemon running. Okay, so let's look at IP link list. You can see here now on the ENS line node interface, it has an XDP program attached here. Okay, so we can also check this way. We can also exec into this SYNPROXY daemon pod, and because I also packaged the XDP loader in this pod, in this container, so we can shoot the hold on. Oh, maybe I needed to. I'm not sure if I shipped this. Yeah, probably I didn't copy. Okay, so let's remove. Let me check my XDP DaemonSet. Which version? Oh, I see. Because in this container image, I did not include the XDP loader program in the container image. So I'm going to remove this DaemonSet and then change the container image version. So now it's it's removed. We can check the link and see here ENS9. There's no XDP program attached here, right? So now let's change the XDP SYNPROXY DaemonSet version. What? Yeah. What? I don't have Vim. That's weird. Oh, anyway, so yeah, I want to change this image to 0.1, which I have the XDP loader program included. So let's now reapply the XDP SYNPROXY DaemonSet. Okay, so let's check. Now it's running, and now let's exec into this part. The XDP node status. So you can see here on this ENS non-node network interface, we have XDP dispatcher attached with another SYNPROXY XDP program with priority 50 attached to the same network interface. Because in this XDP program, I use the libxdp to load and attach the SYNPROXY XDP program to the network interface. So the benefit of this is you can attach multiple XDP programs on this same network interface if you use libxdp library. So I don't want to exclude other XDP program with this SYNPROXY XDP program. So you can build a chain of XDP program on the node network interface and with libxdp. Okay, so yeah, so let's run some traffic load test and see if it's working, if it's a protection, if it's protecting the port on the node. So let's look at our services again. So we have a load port services with 32506 load port. So from our client, here is a client, and let's do a normal curl test to make sure it's working to the load port, right? So this is a load K3S load IP, and this is a load port services. The port it's listening on for each node, and we want to send a curl HTTP request. Let's run a TCP down at the same time to make sure we get the request. So this is a load. Just make sure that's the load with IP load IP 10666. Okay. TCP down. ENS 9 port 32506. That's what we want to send, 32506, right? Okay. So now let's send a request to the node port. It should be working. Okay. Yeah. So we got an Nginx pod response for the load port. Yeah. So we have a TCP down on the node with the client send the request to the load IP and the load port 32506, and the traffic works. Okay. So now let's send a SYN flooding attack to the load port. HPin 3. So this is a HPin 3 SYN flood attack to this load port. And let's launch the flooding. So this is a TCP down still running on the load port, and we don't see any SYN flooding attack here. Why? Because it's dropped by the XDP SYNPROXY, and because TCP down works after XDP program, so we could not see the SYN flooding attack. But we can do this way. we can run a TCP down from the client. Yeah, so let's run a TCP down. Let's give a 50, okay? 50 of I don't want to flood the screen. Let's run TCP down on the load interface with a 50 packet capture and put it in the background, okay? So now let's run the, from this same client, let's run the SYN flood with HP3. Okay, so we see packet here, and we see SYN ACK. So this is the SYN flooding attack to the 32.506 from random source IP address. And we got a SYN ACK from the XDP program attached to the node network interface. So this is a node IP, the node port with back to this random source IP with a SYN ACK. So which means the XDP program is generating a SYN cookie in this SYN ACK back to the random source IP. But since this is a SYN flooding attack, the HP3 client would not send the ACK back to the SYN ACK to ACK the SYN ACK, and so the SYN flooding attack is dropped by the SYNPROXY program, because still here we don't see any SYN packet. Okay, so that's the way we can run XDP SYNPROXY program in a Kubernetes cluster with CNI that is based on net filter or IP tables. In this case, I use K3s and Flannel. And again, if you use Ceiling CNI, this would not work because Ceiling bypass the net filter. And unfortunately, this XDP program still relies on net filter and SYNPROXY modules and a net filter collection tracking to accelerate the SYNPROXY. Okay. Yeah. So again, this is the repo, and it's easy to follow, and so you can test it out, and you don't have to run it in container. You can just run it normal in one single machine with this command. And before that, set up the IP table rules for your interface and your port. But if you want to run in a container, it's fine. If you also run as a DaemonSet in a Kubernetes cluster, that's even better to protect your node. And yeah, so I'm also sending a pull request to bpf-examples repo, and hopefully it can be merged in the bpf-examples, and you can try it out. Okay, so yeah, that's what I want to share. Thank you.